Welcome back, focused learners. Today's explainer has us diving headfirst into a literal powerhouse on the trails, the specialized Turbo Levo Gen 3. Now, looking at the source material, it becomes immediately obvious that keeping a high-performance e-mountain bike like this running smoothly requires a totally different mindset than your standard analog bike. I mean, we really can't just treat it like a traditional trail bike and expect it to survive the season, right? Okay, let's just dive straight into this and see exactly how the guide breaks it all down for us. Here is our game plan for today. We're going to start with the E-MTB reality, move into the motor bay and electrical systems, break down a 50-hour fork service, dial in that suspension tuning, and finally wrap the whole thing up with a bulletproof preventative checklist. All right, Section 1, the E-MTB reality, extreme forces and stress. Let's really look at the physical toll riding takes on this machine out in the wild. 90. That's 90 Newton meters of instant torque acting on the drivetrain. Every single time you push those pedals, the specialized 2.2 motor wakes up and just delivers this massive, relentless surge of power. But what's really fascinating here is what that number actually means for your metal components. Think about it. That instant torque is constantly trying to stretch your chain, wear down your cassette teeth, and literally twist the chassis. The wear and tear components are under a level of constant, high-load stress that standard bikes simply never, ever experience. And then we combine that insane torque with this number, 45. We're talking about a structural frame weight pushing well past 45 pounds. When you've got a machine that heavy paired with that much raw power, the momentum it carries into rock gardens, off drops, and through tight corners is just immense. It's a pretty wild realization of the physics at play here. To keep this bike dialed in, we absolutely have to respect those physics. So let's see how this builds into our first major maintenance zone. Section 2, Motor Bay and Electrical, Preserving the Powerhouse. According to the guide, this is usually the most intimidating part for home mechanics. But honestly, it really doesn't need to be. So, the guide stresses that while the internal drive belt of the motor is completely sealed and, yeah, definitely do not try to open that at home, the external plastic motor shrouds act like massive dirt traps. Every 30 to 50 hours of trail riding, you've got to take those covers off. Underneath, you are guaranteed to find a hidden layer of fine dust, mud, and residual moisture just clinging to the outer aluminum shell. The fix here is super simple but absolutely vital. Wipe this area clean down to the bare metal using a dry or, slightly damp microfiber cloth. Whatever you do, never spray water or harsh degreasers directly into this housing.
Okay, once it's completely clean, we need to talk about protection. The absolutely crucial point here is dielectric grease. What is it? Basically, it's a non-conductive lubricant that acts as an invisible, waterproof barrier. The source material tells us to check the rubber seal on the main battery plug and apply a really clean, light layer of this grease right on the outer rubber lip. This one simple step blocks trail moisture and sweat from creeping in and corroding those highly sensitive electronic pins. Actually, it's more than just a tip. It's an absolute non-negotiable for the lifespan of your E-MTB.
And wow, that brings us to the ultimate golden rule of e-bikes. Never, ever use a pressure washer near this frame. I know, it is incredibly tempting after a muddy ride to just blast the bike clean and be done with it. But the sheer velocity of a high-pressure water stream will so easily defeat the protective gaskets on the motor housing. And worse, it can penetrate the Mastermind TCU right up there on the top tube. So a bucket, a soft brush, and a very gentle hose spray, those are literally your only friends here. Moving right along to Section 3, the 50-hour fork service, specifically breaking down the Fox 36 rhythm fork. We're pivoting from the electrical side to the heavy mechanicals. To maintain that buttery smooth suspension feel, the guide walks us through a really methodical lower leg service. First, you'll completely exhaust the air spring. Then, carefully back off the foot nuts and tap them with a mallet just to break those internal press fits. After that, slide off the lower casting and give everything a really deep clean with pure isopropyl alcohol. And the most satisfying part of the whole job? Dropping fresh new foam rings, absolutely soaked in Fox 20-weight gold oil, right into the clean assembly before you put it all back together. Now, as you slide those lower legs back onto the stanchions at a 45-degree angle, you've really got to pay attention. The rhythm fork uses a grip damper, which means the fluid bath volumes are completely asymmetrical. Through the bottom foot holes, exactly 40 milliliters of Fox 20-weight gold oil goes into the air spring side. But on the damper side, it's just 10 milliliters of Fox 10-weight green oil. Do not mix these up. The grip damper relies entirely on this highly specific chemistry to function the way it's supposed to. Once all those fluids are in, you'll push the shafts all the way home, mount up some fresh crush washers, and torque both bottom nuts to exactly 5.7 Newton meters. Listen, precision is literally everything in suspension work. Do not over-tighten these, or you run the risk of snapping those delicate internal shafts. And let me tell you, that is an incredibly frustrating and super expensive mistake to make at your workbench. Just a clean, precise 5.7.
Section 4. Suspension tuning and dynamics. Dialing in the ride. Having a freshly rebuilt fork is awesome, but if it's not set up for the unique physics of an E-MTB, we're just leaving performance on the table.
Let's compare sag setups for a minute. On your typical analog mountain bike, setting the fork to a standard 25% sag is usually the sweet spot. But remember those extreme forces we talked about earlier? The guide makes a great point here. The Turbo Levo demands a much firmer platform to handle its extra weight and momentum. You actually want to shift your target to a firmer 15 to 20% sag. On the Fox 36, that equates to roughly 32 millimeters of stanchion compression under your full riding weight.
Now, getting to that target sag requires the right inflation technique. When you attach your shock pump to inflate the air chamber, don't just blast it up to the target pressure all in one go. You need to stop every 20 psi, take the pump completely off, and forcefully stroke the fork 10 to 15 times. Why do we do this? Well, it pushes air past a tiny little dimple inside the stanchion, which equalizes the internal negative air chamber with the positive one. If you skip this step, the fork is going to feel incredibly harsh and top out violently, no matter what your PSI says.
The source material also drops a really fantastic setup tip for E-MTB riders. Because of the bike's massive weight, hitting the brakes hard on steep technical lines can cause a ton of heavy front-end dive, which pitches your weight terrifyingly far forward. To counter that, use the gold GRP sweep lever on the top of the right fork leg. By turning it roughly a quarter turn clockwise, you increase the low-speed compression damping. This effectively props the front end right up, preserving your head tube angle and keeping everything balanced when the trail gets gnarly.
Finally, Section 5, Preventative Maintenance Checklist, protecting your hardware. Because, let's be honest, taking care of the small things now is going to save you a massive amount of cash later.
Let's just run through this checklist rapid fire. First up, track your chain stretch. You've got to swap that chain the literal moment it hits 0.5% wear, way before that 90 Newton meters of torque chews up a super expensive cassette. Second, check those chainring bolts periodically, because the motor loves to rattle them loose over time. And finally, occasionally disconnect the rear shock so you can actually feel the linkage bearings by hand. If it feels crunchy or gritty at all, it's time for a service. By staying on top of these core areas, your bike is going to run smoother and last so much longer.
So it all comes down to this final question. Are you ready to master your machine's maintenance and unlock its true trail shredding potential? The modern E-MTB is an absolute engineering marvel, but as we've seen today, preserving that perfection relies entirely on you, the rider. Get the tools out, respect those torque specs, and keep the whole rig clean. Thank you so much for joining me on this explainer as we unpack these insights together. Have fun out there, and I will see you on the trails.